Okay, I start to explain our work in location analytics or scaling location analytics, and we will start to say that my name is Mark and I work in urban analytics team in the mobility and energy R&D department on Barcelona Digital, the Digital Centre. And we are a small group, 5 people now. And we decide to avoid the discussion between scientific and engineering walls. And we have a group with data scientists that know how to code, and I mean how properly code, and working together with data engineers that claim to understand what a regression is. Okay, and we have these both skills on a team, and also we have managers that are trying to do some useful things like sell our work. And we work with this team, and we are doing applied research, and we try to fix the city using the data that we can have about this city. Okay, then urban analytics is try to make data explain the city, how the people and the objects in the city behave. We call this city chronotype. For instance, we are doing some questions like, where are the people gathering? Where are they going? Where do they come from? What's in there? Why are they going there? What looking for? Something like that. Some questions related with city and related with places. And we are working on private and public funded R&D projects, but always with real systems, with good performance and with very good scalability requirements. Because the pilots are not useful for us, because we need to show this to the private and the public sector, but a final client that wants to use really this product. Our data, we work with the data that comes from the cities. Cities are, for us, geospatial items. For us, cities do express through their geospatial attributes. For us, the city have all the entities that the city have location attributes, latitude and longitude. And behind this latitude and longitude, we look for a behavior, a dynamics, a phenomena that can be founded in this type of data. This means that we use the location data to try to look for a relation, some concepts in a big complex system that is a city. Some applications where in the next slides will come some specific use cases, but in high level, we can explain 3 different use cases, like mobility use case, by meaning traffic data, and we try to cross the traffic data with some context variables like meteorology, events, or calendars, something like that, to try to do a predictor using these context variables, use a predictor to know which status or which incidents will be in this city. Also, use cases are the work on the sustainability, studying the trajectory mining between public transport users to improve the public transport network, and also the retail sector trying to characterize the geospatial behavior of the customers. And after this so boring marketing stuff, we will continue and let's go with the real things. And we will start with the science behind this, our work. And I will start with the definition of spatial data analytics. Spatial data analytics or spatial statistics includes any of the formal techniques which studies entities using their topological, geometrical, or geographic properties. This means that the basic types of our work, basic types of our attributes are geometric types like point, line, or polygon, or other classes and subclasses of these types, like the multi-point, multi-polygon, multi-line, the curves, the surfaces, and all these types have a parent that is the type geometry. These types have also some basic operations, like the very basic operation that is very used is contains or within, are very similar operations, but in opposite directions. For instance, contains the definition is true when no points in V lie in the exterior of A, and in opposite side, within is true when all points in A lie in the interior of B. Other operations is equals or disjoin, touches, crosses, overlaps, and the main one that we use for a lot of algorithms is the distance. The distance in 2 dimensions and also in 3 dimensions. And other more complex operations like union, difference, intersection, symmetric difference, and these are some utilities that are very useful for our algorithms, like buffering to change the form of the geometrical types, or a convex hull that transform multi-points or multi-lines in one big polygon. Also, the operation to know the area of polygons or multi-polygons, and all these basic operations is used for us to do something like that. These are data mining techniques on geospatial, and these are 2 examples. This one is a DB scan, a density-based clustering, and this one is a optics clustering. This is a radical clustering, and this is a statistical clustering. And we are doing this to try to look for some relations between the points and the lines and the polygons in the city. Also, we are doing some heat maps using these urban data, and some other data mining techniques or machine learning techniques like trajectory mining. These are 3 examples, but there are some others like a simple geospatial querying, look for spatial anomalies and some outliers, geographically weather regression, self-organizing maps, agent-based modeling. These are a battery of some algorithms that we are using on our research group. And I can explain 2 specific use cases with a real client behind. And the first one is the customer activity tracking. The client is, in this case, is a bank that have a big data set of transactions. And we are trying to know where does people buy and what is the profile of the buyer using geospatial data to inform this bank about their customers. And also, we have a data set from the traffic status in Spain and some other countries in Europe. And we are trying to do a predict using geospatial attributes and also other context variables. The datasets that we are using for these cases are, for instance, data from social networks like Twitter. Twitter have all the tweets that are geolocated have a point, and in this case, we only use the geolocated Twitter tweets. We have data from meteorology that the behavior of this meteorology is included inside the polygon. We have a traffic status that is defined as a multi-line. A traffic incidence is defined as a multi-point. Credit card operations is also a multi-point. Demographic have points and also polygons. And shapefiles, that is the shapefiles is the files that define some political geographic distributions, like postal codes or like a province, something like that. We need to use this data. This sometimes or never, this data is big data, but it's very useful to use with the other data and for the real proposals. Then we have this data. We have this technique, the clustering technique in our tool set, the heat maps, the anomaly detection, the trajectory mining, and some facilities on queries. And we are, all these use cases and all these applications are based in some different stacks that we are using. We don't have only one stack, we have several stacks, depend of the type of data and the volume of data. Then, of course, not all our use cases are big data. And we use the most powerful open source database in geolocation operation, that is Postgres, Postgres with a GIS module. This database have all the operations, geometric operations implemented, and it's very useful to do some analytics in geospatial, but it's a relation database, and not all the times we have relational data, and sometimes we have a huge volume of data, and it's not possible only use Postgres. We have all our stacks deployed on Amazon, and when we are using only for all style or all school stack, we have the Postgres on RDS, and we also use some MongoDB and DynamoDB on Amazon with Java or Python applications inside, and some APIs or using directly the SQL interface to do some exploratory works, visual works, or a real application. But when we have problems, when we have big data problems, we need to extend this stack, and now we are doing, we are using Hadoop, but Hadoop with GIS tools. GIS tools is an extension of Hadoop, is an open source project, and is from Esri. Esri is a company that in the past have a lot of products, but not open source, private products. And this is, the GIS tools is the first open source product of this company. And is a model that is doing geospatial capabilities to the Hive interface and also to the MapReduce. Then our stack have this all style part, but also have the HDFS from using Elastic MapReduce, and over a Hadoop with GIS tools. Then we have also Peak and Hive as default, but we have also a GeoHive. GeoHive is extension of Hive with geospatial operations. Like in the case of PostGIS, that have a SQL interface, but with some geographical verbs, like within, like contains, like near, like distance, something like that. And this is the case of GeoHive, that is Hive, with this geospatial data. But also exists Java API that can be used inside the MapReduce jobs. And then it's possible to do a MapReduce job with a special operations inside. Then our complete stack is use some capabilities of all school stack. For instance, we have all the shape files in here, and also the outputs, because we try to have outputs that are not big data. And we use Hadoop GIS to use Hive and use MapReduce to create these algorithms in a scalable mode. But after this process, we have only some raw outputs in table forms or only in data form, and we want to show this data in visuals. To do this process, we are putting all the outputs of this stack inside Elasticsearch, indexed in Elasticsearch. And in the top of Elasticsearch, we have a Kibana product. Then we are using Elasticsearch for some simple queries, but normally we are using this Elasticsearch to print, to draw the data that are coming from Hadoop and Hadoop GIS stack. Then we have a geoprocess, but in batch. We can do a near real time doing workflow of jobs. We have this, we can use some basic geo operations, and we need to do manual workflow composition. The things that we are not doing now is we are not working with geostreams. We are not have real time. There are some geographic operations that are not included on Hadoop GIS, and then it's not possible to do this type of projects. And also the workflows are not automatic. We need to compose manually all the workflows in our stack. At the end, this is the next steps. We want to use in this, for the geolocation analytics, we want to use Spark and also Apache Storm to try to get these real-time capabilities in our project, and also try to use the geospatial capabilities of column databases like Cassandra or Neo4j that are very preliminary capabilities, but we think that in the future will be a good tool and a powerful tool. Okay, that's our workflow and our stack to do this geospatial analytics in big data context. And I want now to ask you for some comments about our stack, and if you know some other techniques or other tools, they are welcome. There are some questions or comments?
No questions?
Okay, thanks.